Oh my goodness, look, we're already on part 2 of trig equations. That means we're going to look at second degree trigonometric equations in one function. So know this one function part. That means we're not dealing with both sine and cosine at the same time in the same equation. Now just one at a time. Like this one. This one has cosine. One of them's cosine squared, sure, but it's cosine. So the squared thingy means that we are dealing with a second degree trig equation. And how would I handle this? I would handle this the same way I would handle a second degree polynomial equation. So if I had something like 0 equals x squared minus 5x minus 6, my first go-to would be factoring. If I can factor that, I'm going to factor it. But if I can't factor it, and well, sure, that one I can. If I'm dealing with 2x squared minus 20x plus, I don't know what's a good number these days, 4. That's something I cannot factor. And if I can't factor that, I'm going to have to use, well, I could complete the square, but I've got better things to do. I'm probably going to use the quadratic formula. So those are the main two options. I'm going to factor, and if I can't, I'm going to use the quadratic formula. I'm going to do the same thing with these second degree trig equations. My first go-to will be like factoring after I get everything to one side. And if that doesn't work, quad formula, here we go. This one's a non-calculator one, so my hope is that it probably works out to something I don't have to use the quadratic formula one for. But let's see. We're told that 2 cos squared of x is equal to cos x. Ooh, you know what's really tempting? Is dividing both sides by cos x and just saying that 2 cos of x is equal to 1. But that would be bad. Don't do that. Avoid dividing by your variable, because if you divide by your variable, you're going to eliminate an answer. That would just be so sad. It's not that this 2 cos x equals 1 isn't an answer. It's an answer. It's not the answer. So rather than divide by that, we're going to use our sick factoring skills. I'll bring everything to the same side first, as I would in a quadratic equation. And from here, I will factor out cos of x. So I haven't divided by cos x. I've factored it out. It still exists. As with when you've got solving quadratic equations by factoring, you can separate this into two cases. Case 1 is that cos of x is equal to 0. Case 2 is that 2 cos of x minus 1 is equal to 0. And you solve each of those cases. This one says 2 cos of x is equal to 1. Therefore, cos of x is 1/2. If cos of x is 0, that's a case where we're probably dealing with x being pi over 2 or 3 pi over 2. You can consider getting that from unit circle, since, our x value on the unit circle is cosine of theta. We know that we're here, or we're here. Or if you don't want to do it that way, just consider what the function looks like. And we see it reaches 0 when x is pi over 2 and 3 pi over 2. But have some means of solving that one. This other one is a special triangle. It's related to special angles. Again, have some way to access it. But in any case, you should be able to get that it's pi over 3. Now, I don't even know if this is actually in terms of pi for final answer. What do we see? Oh, thank goodness. So 0 to 2 pi. Nice. So I don't have to do anything coterminal to any of these. I don't have to translate from degrees to radians either. So I can just straight up say my final answer, where x is going to be one of these. It could be pi over 2, it could be 3 pi over 2, and it could be pi over 3. All of those answers are valid. All of them will solve this equation. Neat. Well, quick, try this other one. And there's like 2 others after it. But let's see where we go. Oh gosh. No, it's okay. I know how to factor. This is fine. This is fine. Honestly, if you have trouble factoring, go to your good friend scrap paper. And on your scrap paper, do something like 3y squared minus 7y plus 2. And factor that. And then you can do things with it. There's probably going to be like a minus 2 and a minus 1 involved if I were to guess. That's on your scrap paper. Or box it off, section it off, write the word scrap so we know it's not your actual work for this question. Your actual work for this question would most ideally just maintain the trig function. So I would say, instead of 3y minus 1, I would say 3 cosecant of x minus 1. And instead of y minus 2, I'd say cosecant of x minus 2. So we see that similarity in the factoring, that they are tied together. It is possible to involve this in your actual work instead of just your scrap work, but then you do have to make sure you define what y is. And you would have to say, let y equal cosecant of x, and then write this stuff and equal 0. I'd say it's probably faster to just straight up do it on scrap paper. You don't have to worry about the kind of communication errors that might pop up or changing equations into expressions, etc. Anyways, these give us 2 possibilities. One possibility is that the cosecant of x is a third. And this possibility is that the cosecant of x is 2. Again, I don't know how to deal with cosecant, all these secondary trig functions. What do they think they're doing? I'm all about those primary trig functions. So this is related to sine, and we'd get it by taking the reciprocal. Wicked. Oh my goodness, we've seen this before. That's a case where we have no solution. But this is a case where we're dealing with 30 degrees or pi over 6. Actually, there's also another one, 5 pi over 6. And that's what we have to involve in our solution. So we've got that. We have a solution for this half of things. This one, it doesn't matter to us anymore. But that's what we're dealing with. That's not a reference angle for talking about both of them. And we just have to make sure it's in this domain of negative 3 pi to 3 pi. So if I subtract 2 pi from each of these, I can go with, what is that, 12 pi, so negative 11 pi. I'm going to change font color, sorry. Negative 11 pi over 6 is coterminal to pi over 6. And I could maybe subtract another 2 pi. Who knows how far this thing can go. Negative 23 pi over 6. Okay. And this one, if we subtract 2 pi, negative 7 pi over 6, negative 19 pi over 6. We could also add 2 pi to those. So 13 pi over 6, or 25 pi over 6. We're adding 2 pi to this. 17 pi over 6, or 29 pi over 6. So all of these will give us solutions to that equation. Of course, we're only looking at negative 3 pi to 3 pi. So not all of these will work. Which color do I want? Purple. So this isn't lower than negative 3 pi, so that's okay. And these ones are okay. This is lower than negative 3 pi. Negative 3 pi would be like negative 18 pi over 6, so that's a nosy. 13 pi over 6 is okay. That's less than 3 pi. 25 pi over 6, that's like more than 4 pi, so that's a no as well. And this one's okay. Oh, this one's so close to negative 3 pi, but it's just out of bounds. So that's a no. And this is a little less than 3 pi, so that's good. That one's a no. You don't have to do your process like this where you write everything out and cross it out, but if you're having trouble seeing what's within range and what is outside of it, then it might be a handy method. In any case, x can be any one of the circled things. So it could be negative 11 pi over 6, negative 7 pi over 6, pi over 6, 5 pi over 6, 13 pi over 6, or 17 pi over 6. Those are the options for x that will solve this equation over this domain. And that's that. Phew! What a doozy. Well, here's another one. Ooh, calculator time. Rip. Good luck. Don't worry, I'll be here with you. In fact, we should probably do this one together. So, is this even, it might be that it's factorable, but it doesn't work out to give us nice ratios, or we might have one that just doesn't even work for factoring. If I look at this, I think this one is factorable. So if I've got 8 sine squared x minus 10 sine x minus 3 equals 0. Feel free to try it, see how far you get with it. At some point you might need a calculator, that's okay. What am I looking at? Probably need a 12 and a 2, which means I need a 4 sine x and a 2 sine x. Nailed it, I think. This looks legit to me. Don't forget my equals 0. Wicked. This tells me that sine x is negative 1/4. This one tells me that sine of x is 3 over 2. That's not happening. That's way too big. But this one is. So my reference angle is, I'm in degrees. Excellent, my calculator is already there. Wicked. And so inverse sine of 1/4 will give me 14.478 degrees. And from there I can just get all my values. X can be 14.478 degrees. It can be, not 14. Get out of here. Who wrote down that answer? Not me. It's not there. Negative for sine ratio, so quadrants 3 and 4. So plus 180 should be like 194.48 degrees, or 360 minus that, which is negative 345.522 degrees. Wicked. And that's taking us all the way up. Oops, I wrote down a negative there. What in the world? There we go. So that takes us all the way up to 360 degrees, but we can also go coterminal by taking off a revolution. So each of those minus 2 pi, so minus 360 degrees. So 194.478 is coterminal with negative 165.522 degrees. And then 345.522 minus 360 will, give me the negative version of that. So negative 14.478 degrees. Things we should be noticing, there's a lot of similarities between how we finished these off for right now with quadratic ones and how we finish things off for more linear trig equations or first degree trig equations. The key thing is just making sure we can separate this into cases. This one, we can also separate into cases, but it's going to be, what's the word? A doozy? Because this is not factorable. And you can try factoring it if you want. I'll just, like, spoilers, it's not factorable. So how on earth do you deal with something like this? And as I mentioned earlier, that's where the quadratic formula comes into play, where secant of theta will be, well, negative b plus or minus the square root of b squared minus 4ac all over 2a, which is on your formula sheet. But if you memorize it, it'll be that much faster. So 4 plus or minus the square root of negative 4 squared is 16 minus 4 times 2 times negative 1 all over 4. And we're just now working with that. Yoicks. So 4 plus or minus the square root of 24 over 4. We can simplify the radical if we want. We don't have to. I would just, at this point, say secant of theta is 4 plus root 24 over 4, or secant of theta is 4 minus root 24 over 4, and get values for each of those. So 4 plus, where the heck's my root button? Root 24 is something divided by 4. I get 2.22474-ish, say. And that means I can say that cosine of theta is the reciprocal of that. 0.44949-ish. Over here, secant of theta would be 4 minus square root of 24 divided by 4, which is negative 0.22474. Interesting. And that means that cosine of theta is the reciprocal of that, which is negative 4.4495-ish. Oh, that took a lot out of me. Anyways, we gotta finish this thing off. Whoa! That is no solution. Nice try, cosine. You can't be below negative 1. Don't know what it thought it was doing, but it wasn't doing it right. And now for this one, we can get a reference angle. So inverse cosine of that, let me go back to get more exact things in my calculator. Root of 24, divide that thing by 4, take its reciprocal, and then take the inverse cosine of that answer. And I'm getting 63 point, oh wait, what mode am I in? Radians? Come on. Yeah. Radians. That divided by 4, reciprocal. And now inverse cosine of my answer is 1.10460. It's got some other things in there. That's the reference angle. What do I want? General solution. Okay, well, that makes things a bit better. So in quadrant 1, we're dealing with 1.10460. In quadrant 2, not quadrant 2, cosine's positive, so quadrant 4, 2 pi minus that is 5.17858 and some other things. Irrelevant. All that matters here is that theta could be our first thing. Let's round properly. Plus anything, or anything coterminal to it. Or this second thing, 1.7 9 plus 2k pi. And if it's coterminal, then those k's better be integers. And that is that. Whew, what a doozy. Those quadratic formula ones, they can be really involved just because of this process here. You recognize that it can be a pain, but it is very doable. So multiple reasons why you might have to use calculator, because it's not factorable, or perhaps because it's not a special ratio. But in any of those cases, be ready for it. There is some practice work. Wow! A lot of stuff to play with. It does indicate whether it's a calculator or non-calculator question. So do give that a look-see with your eyeballs. And that's it, that's all. If you have questions, don't forget to let me know. I will help you with the help that you need, but you do have to ask. Tell everyone I say math is fun, and tell everyone that you say math is fun, because we all know that it is. Trig identities for the, no wait, trig equations for the win. Okay, bye.